Previously here on Project Rio Tiny Basic Computers version 2, we started our new colour 8-bit build, including an introduction to the Arduino Mega 2560. Well, today in episode 2 of the new series, we're going to add Pi, allowing our build to run standalone for the very first time. Hello and welcome to Project Rio from youtube.com/Wi-Fi Sheep with me, Tom. In this new series, we're going to build a new real 8-bit programmable computer with new or almost new, easily accessible off-the-shelf parts. Today we're going to add Raspberry Pi to our build project. The Pi will act as our dumb terminal, and thanks to PiGFX, the Pi hardware will handle HDMI and composite video, our higher res graphics and colour, and, for the first time, USB keyboard drivers. So you won't need to try and find a PS2 compatible keyboard for this build. We will, however, need to do a bit of soldering, which is unavoidable. If you're just joining us here on episode 2, then I highly recommend starting at the beginning with episode 1 and following along from there. Throughout this and many other projects here on Wi-Fi Sheep, it's been fantastic to partner with PCBWay.com, the #1 solution for all your turnkey PCB manufacturing and assembly needs. If you're like me and have a growing list of hobbyist or even commercial electronics or design engineering projects, then having PCBWay services at your disposal is truly invaluable. So if not done so already, do go and take a look at PCBWay.com and sign up for your free account. Having your own professional custom PCBs made really opens up so many possibilities. For professional quality PCB manufacturer and so much more, head over to PCBWay.com right now. Details and links are in the description. So for the start of part 2, you should have an Arduino Mega 2560, something that looks a little bit like this, and it should be pre-flashed and running the Rio Tiny Basic kernel. If you haven't got to that stage yet, go back to episode 1, follow all the instructions through, and then rejoin us here at part 2. So today we're going to make this machine run independently. At the moment, we need to plug this via USB into another laptop or other device that's capable of showing us basically the output via a terminal. We now want to try and add something to this to make it run independent. Now, after much thought and consideration, for Project Rio, I am going with the Raspberry Pi. Now, I know this was slightly controversial because the Raspberry Pi is in itself a single standalone computer. But there's an extremely good library called PiGFX that means that the Raspberry Pi can actually run as a standalone dumb terminal outside of the traditional Linux operating systems. For this build, we're going to use a first generation original Raspberry Pi. You can't buy these brand new anymore, although there may be some new old stock lying around, but you can pick these up relatively cheaply secondhand. Alternatively, I highly recommend the Raspberry Pi Zero, which you can buy brand new. You need the original Zeros, not the 02s. It's overkill to use a 02. However, you will need ones that either have the pin header installed or you will have to solder and install a pin header yourself. The heatsink isn't necessary. I've just added that to this particular board that I had lying around. Obviously, bear in mind with the Zeros, you will need a HDMI adapter to adapt up from the mini HDMI to the full HDMI standard. And also, if you want composite video, there is 2 pins need populating, or pin spaces, holes rather, that need populating here, and you can get composite video out of one of these. That's one of the reasons I like the original Pis. They're cheaply available at the moment. There's still many of these around. They're more than capable for what we need, and as well as full HDMI, they have a full RCA phono jack. Now, one problem with attaching a Mega to a Raspberry Pi is something called TTL voltage logic. You see, the Arduino platform outputs on all its pins on 5 volts. The GPIO, that's this array of pins here, on any Raspberry Pi at the moment, are not capable of supporting 5 volts. Some kind of manage it, others will be damaged, like these original Pi ones will be broken or damaged if you put 5 volts into the GPIOs directly, as the GPIOs here are only 3.3 volt tolerant. So we've got a mismatch. We've got 5 volts over here and 3.3 volts over here. So we need some sort of solution. And the solution to link these two together safely is to use what's called a level shifter, which is this tiny little device here. Now, these can be picked up extremely cheaply, but they normally come as little solder kits. So you have a PCB with these level shifter diodes on, and you also have a piece of pin header. What these allow you to do is to link a high voltage switching signal into a low voltage switching signal, and vice versa. They run both ways. And this particular unit has 4 channels. We only actually need 2 channels on this device, but unfortunately we do have to do a little bit of soldering to assemble this. I have searched online. I've not found anybody doing these pre-soldered, which is a shame. However, soldering isn't the end of the world, and that's what we're going to do shortly. You're also going to need a piece of solderless breadboard in order to mount everything on. These can actually be quite useful for setting up and mounting things up for soldering. This is the small, I think these are 480 pin. They're the smaller ones that we're going to use. We don't need a full-sized breadboard for this. We can use one of these half-sized boards, as we're purely going to be mounting the components, linking and bridging these two together. Okay, so soldering. A lot of people are scared of soldering, and I get a lot of criticism saying I don't solder very well or don't do it properly, blah, 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 blah. All I will say is this is the way I do it. It works for me, and I'm very happy with it, and I'll show you what I do, and you can copy it or you can find your own way. It doesn't really matter as long as it gets the job done and done well. Okay, so soldering iron is just here and just heating up, and I got a piece of wet sponge. If you haven't got the little pad that some of the soldering irons have in their stands, just get a piece of kitchen sponge. That's all this is, because it's already a bit charred already. Dampen it down, and then you can use the wet sponge just to clean up the end of the soldering iron, and it just removes any, especially if it's been used before, like mine is used and abused quite a lot. So we can just clean up the soldering iron. There we go, something like that. Okay, best if you can use a thin core solder, which is what I've got. This stuff I've had for over a decade. It's lasted forever, which is fantastic. And most importantly, flux. There's a myth going around that you can solder without flux, and the flux is in the solder, blah, blah, blah. It's a load of BS, in all honesty. Use a proper external flux. You can get away with, I'm just thinking if I've got it here, yes I have. You can get away with something like a DIY store plumber's flux. It's a paste that you apply. We can see a few sticks and things in there from when I have been using it before. It is highly corrosive though, so you do need to be careful. You see this green gunk on the outside? That's actually metal that's corroded, and it goes green. You can use it. I don't recommend using it because it is corrosive, so if you don't completely clean it up afterwards, you need soap water cleaning agents to actually remove the residues from your work. If you don't, it'll go crusty and start breaking down and actually eating the metal of what you've just soldered. So I advise against using this, but can if you've got nothing else. What I actually use, which is much better, is this stuff, which you can order online. This is Topnic RF 800, and it's an alcohol-based flux, which means it evaporates. It doesn't corrode anything, and it's designed for electronics like this, and you don't have to clean it up afterwards. So it's what I use, and I really do think it's much better. Health and safety warning: do be careful with fluxes, especially with the soldering as well. Well ventilated room, take breaks where possible, wear protection if needed, and just be aware we're dealing with chemicals, and obviously this stuff is particularly nasty for if you suffer from respiratory issues. That aside, let's get going with the project. So we're going to solder up the pins onto this level shifter. These kits normally come just with a single piece of header, and we need to cut the header equally down the middle. And I'm just using a pair of snips. You can use a knife. Just make sure you do actually get it in the middle. There we go. And that should cut into 2 equal parts, which it does. The breadboard is here because it can be quite useful just to use it to prop things together so we can keep everything still, especially when we're soldering things together that need legs. So it's long leg down into the board. And I'm just going to push that piece of header in there. And then I'm just going to see where I need to position there then. The other one. Okay, so the two headers are in. I'm going to just pop the board in like that. So that's now as we want it assembled. And we're just going to solder across the top. So, really easy to do. I know a lot of people are kind of scared about soldering, but it is really easy to do. So we're just going to apply some paste. Or in this case, it's more like a liquid. Just on the top. I can already smell it, so yeah, you do have to be very careful with that stuff. Soldering iron out. Solder. Just bring the solder to touch where you want to solder. We're just going to heat up. And there you go, and it just melts straight into the hole, no problem. What I suggest doing is do both sides just in the corners. And that will secure the pin header on. There we go. So that's now not going anywhere. Now I can just run down each pin individually. Just don't get your fingers too near to the iron because it is burning at, I forget how many 100-degree centigrade it is, but it's high. It's about nearly 200 on these, I think. Also, you've got plenty of flux. You won't bridge the pins. Can put a little bit more on if it's looking a little bit shallow. Just touch that one up there. So that's it done. It's as simple as that. And that's now ready. Right, soldering iron is now off. That is literally all the soldering we'll need to do unless you're using the Raspberry Pi Zero and don't have the header attached or are going to attach composite, then you will need to solder up one of these as well. If you're not using that and you're just using an off-the-shelf board like we will be doing, then that really is all the soldering that's required. So we've got this component. Our level shifter now ready. We can leave it on this side of the board. Now we've got two different voltages, so we've got two sets of power rails independent to each other, top and bottom of the board. The top will be our 5 volts, the bottom will be our 3.3 volts. I've also got here a kit of jumper wires. You can pick these up very cheap as well, and they're very useful to have. And we're just going to select some wires now. They usually come in sort of little bags like this of predetermined colour and length. It's not an exact science. As long as you get the circuit right, it doesn't particularly matter which ones you use. So what we're going to do is we're going to link the two grounds together. This is the minus or the blue rails. Bear in mind, make sure you have the board with the plus rails on the top. So don't have the board upside down with blue on top because that can cause problems. So we're going red on top. And I've got one of these orange long cables. What we can do is we can just bend with our fingers the ends. And we're just going to link the two grounds together. There we go. Now on the board, on the silk screen, if I don't know if it will come up in camera, there's two pins which are here and here, which are labelled as G and D. These are also ground and they need to be linked to the blue line. So we can do that with some smaller jumpers. So this part of the breadboard, all these lines are connected. There's a split in the middle. So this row here and this row here are separate, but the rows are actually linked together, or columns I should say. Columns are linked together, rows at the top are also linked together. So what we can do is we need to link our two grounds together. And some of these can be a little bit stubborn to go in sometimes, so a little bit of patience is needed, especially if it's a new breadboard. And you might need a longer pin at the bottom or jumper wire just to, again, link ground onto the blue rail. Okay, so it's now ground and ground is now linked. Next to it, on the silk screen, there's something called HV and LV. So HV is high voltage, LV is low voltage. Now, this top rail will be high voltage and the bottom rail will be low voltage. High voltage is 5 volts, low voltage is 3.3 volts. So again, as like we've just done with ground, but we'll use some orange for this, is we're just going to link the next pin to high voltage on the top and low voltage on the bottom. The next thing we need to do is look at how we're going to incorporate our two boards. So we've got Raspberry Pi one side and we've got our Arduino the other. Now, for the benefit of this project, we're going to power through the Raspberry Pi. So the Raspberry Pi will be the main power source. From the GPIO then, we need to jump power across to power up the Arduino because it will rely solely on the Pi for its power supply. So what we need to do is jump 5 volts straight across. And the best way to do that is to use some jumper lead. Now, jumper wires you can buy in these sort of packs. Now we're going to need two types. We're going to need male to male and we're going to need male to female. And you buy them you can buy them cheaply in these packs. These rainbow leads, you just pull apart what you want. I've actually got a few that I've pulled apart already. So this is male to female. And on the Raspberry Pi jumper, first of all, let's do 5 volts and ground. So we start in this top corner here on the Pi jumper. And you see where it's marked P1. P1 is 3.3 volts. Above it is 5 volts. There's then 5 volts and then ground. So it's 5, 1, 2, which is pin 3, which is ground. And where we have the male pin side, we want to go ground onto blue. Anywhere on this rail will do. And 5 volts. Okay. Now, the Mega is slightly different. Instead of having pins, it has pin sockets. So we need male to male cables. Here we are, red and black here. And all we'll do is we're going to go 5 volts, that's off the rail we just put on from the Pi. Ground. And on here, we've got, along this line here, we have, it's upside down, unfortunately, to you on the camera, but it's ground is, we've got voltage and we've got ground, and voltage, which is VIN, is there. Okay. So that now should work. When the Pi powers up, it should give power to the Arduino. We've also now powered the high voltage side of our level shifter. Now, what about the low voltage side? Well, both of these devices have what are called voltage regulators on board, which in the big size look a bit like that. They have very small versions on board, both the Pi, I believe that's the voltage regulator right there. See, it's a sort of mini version of one of those sitting flat. And the voltage regulator is that device there on the Arduino Mega. Now you can use either one of them. What they'll do is they'll take 5 volts. You see there's touch two of them here to take 5 volts, and you can take it down to 3.3 volts. So you can run from either side, but we need to get a 3.3 volt voltage. So on the Arduino, there is a pin labeled 3.3V, which is 1, 2, 3, 4 pins down on that side. And we're simply going to put that, and we only need the lone pin on its own, onto the plus rail this side. So bearing in mind we are all grounded, so we loop the ground through here and we go back that way. So we don't need a separate black wire for 3.3 volts. So we've now got 5 volts this side, 3.3 volts this side. Okay, next we're going to look at setting up a UART. This is how the Tiny Basic computer system actually works. By sending a UART serial protocol, two boards can talk to each other, and that's why we needed this level shifter, just to take the voltage of the talking down to make sure we don't damage the Pi. Now, on the Raspberry Pi, the 2 pins next to the ground, which I don't know if you can see that, if I just bring that into view. So on the top row, I'm going to find a pen so I can point things out. There's the ground here, and then the next 2 pins, this one, are what we call the UART channel, TX and RX. Transmit and receive. Transmit will be orange. Receive will be yellow. And they go straight on like that. The 2 pins here then need to go onto the 2 of the 4 available channels on the low voltage side. So that's this side. Very important, this low voltage, 3.3 volts. So a bit of a stretch here, but we'll get this just to stretch over. So just for convenience, over this side, I'm going to go on channel 3 and 4 on the low side. So TX will be channel 3 and RX will be channel 4, and we just pop those in like that. Okay, so that's the wiring done for the Pi side, believe it or not. We just now need to add 2 more wires to jump the signal, so it's going to go back this side over to the Arduino. For that, I've got a male to male green and brown jumper lead, separate this time. Now, you don't go TX to TX or RX to RX. You actually need to swap. So transmitting from this side, TX, needs to be received, or RX, this side. And when the Pi transmits on TX, it needs to be received on the Arduino. So we need to swap the cables round. TX and RX, there's a couple of TX and RXs or UARTs on here. We actually want to go with 0. So it's here, TX 0 is on 1, which is there. And TX wants to go to RX. So we're going to put it on the high side of channel 4, which is there. Next to it is receive, which is 0. And this wants to go to transmit on the other side. So we're going to put it into channel 3 on the high voltage side. And that should basically be it for wiring. Okay, so we're nearly ready to go, but we're using a Raspberry Pi, and Raspberry Pis don't do anything unless they have an SD card installed. They need an image. The image we're going to use is called PiGFX. It's free, and you can download it from GitHub. I'll put a link in the description. The only thing about the GitHub version is it doesn't work straight out the box, even though it claims to. You do actually have to add some additional files and be competent in building up a Raspberry Pi disk image that the Pi can actually use. If you're not competent in that, then don't worry. If you join us on the Wi-Fi Sheet Project Rio Patreon, I've already created a pre-installed directory for you. There will be a drive link, and that will take you through to a Google Drive. And from here, you'll see Raspberry Pi terminal. Inside, you'll find TBC PiGFX. Here's actually the files that I've set up for a full bootable version of the Raspberry Pi PiGFX terminal. All you have to do is click the 3 dots on the side and click to download this folder. Okay, so once you've downloaded that, extract the zip file, and inside you'll find a complete list of all the required files and kernels and firmwares, etc. needed to boot PiGFX as a standalone terminal on any Raspberry Pi up to a Raspberry Pi 4, although I don't recommend 4. I recommend anything from 0 up to the 3B Plus should be fine. All I need to do is copy the files. I've inserted a new fresh blank SD card, which is here, and I'm just going to paste those straight in. And that's all you have to do. That's now installed. There's no need to do any flashing, any image writing, anything like that. It's simply the case you can copy and paste these files, and PiGFX works really well. So with that done, we can now eject the SD card and we'll return to the main build. So what we should have is a micro SD card, something like this. You don't need to have a big card. This, I think, 16 gig, but you don't need a big card. There's basically nothing on this. We're not running a full Linux. Bearing in mind, if you're running with the original Raspberry Pi like I am, you're going to have a full-size SD card, not the micro SD cards that became later standard. So all I need for this to work is an adapter to adapt the card up. And I'm going to pop that in. Okay, so we're nearly ready to go. I'm just going to turn the Pi around for convenience. And I've got a Raspberry Pi compatible power supply. This one is actually originally for a Pi 2. It's 5 volts, 2000 milliamps. It'll be enough to do it. I would recommend the Pi 3 supplies, which do kick out a little bit more power. And we're just going to plug in, as we normally would, into the power slot on the Pi. There we go. Next, we need a USB keyboard, and unlike the previous Tiny Basic Computers project, we don't need a PS2 standard. We can use a standard USB keyboard. And if you're running with a big enough power supply, you can actually use an Apple device, but I wouldn't recommend it. If you can get a cheap generic PC keyboard, USB, like I'm just going to use here, I would use that instead. Just plug straight into the Raspberry Pi, as you normally would for attaching a keyboard, and that's all we have to do. Okay, so moment of truth, we have the system set up. By the way, just because my brown wire is a bit ropey, I've swapped it for a white wire, but that's the only issue. Okay, so that's why that's changed. But other than that, we're all good. Okay, so everything is set up how I showed you. Let's now cut to the feed itself. There we go. And let's power up and see what happens. So that's the Pi boot kernel for PiGFX. And there we are, that's Project Rio kicking in the Mega Color Edition. And it's flashing cursor. So I've got the USB keyboard. This is just a stock USB keyboard, no PS2 protocol involved. Let's see if we can actually type anything in. So we can go hashtag, oops, there we are, hashtag. By the way, the keyboard's mapped a bit funny on this, but you'll notice I can actually type and I can backspace delete, which is something you couldn't do on the previous Tiny Basic Computers system. There was no direct delete. There is on Project Rio. So I can go hashtag mem, and that will give me the memory in the system. By the way, don't worry about there being an SD card error. That's because we haven't installed an SD card reader or file system into this build as yet. That's what we'll do next time. One thing you may need to do is look at your user bytes, which is the EEPROM space. Now this might come back as 1 or 0 bytes. In that case, we'll need to clear it. We can do that by simply asking E format. Now bearing in mind this is a solid 4K of EEPROM space, so it takes a little moment just to initialize. There we go, it's done. Now if I go hashtag and mem one more time, you can see that it's now initialized and we've got the correct full user bytes available to Project Rio. Also commands like CLS now work, and we can do things like color commands by simply calling fcol, and if I say 0, it'll change the font to black. Let's change that back, so I'll go fcol, I think it's 7, or go back to white. And if I now go bcol 0, put the background to black, if I now clear, I can have basically whatever color text I want on whatever color background I want within a choice of 256 colors. So it's a little bit of a scrappy mess at the minute, but our basic independent self-running Project Rio system is now independently self-running. And as you can see, it's a really minimalist and simple build that works really well and gives you a quite powerful independent programmable computing platform. So hopefully you now have a base fully standalone Project Rio system up and running. Next time we'll add SD card filing support and reintroduce sound and output to our build. And a reminder, if you want to join in, you'll need to join the Wi-Fi Sheet Patreon and the £6, $8 Project Rio tier. If you haven't done so already, please do consider liking and subscribing the channel. and I'll see you again for the next instalment of Project Rio Tiny Basic Computers 2 right here on youtube.com/Wi-Fi Sheep.